Guys, you know what time it is? It is 1 p.m. We are ready to go live. So here we go. Hang on. You guys ready?
All right, Melissa, you ready to get this started?
Yeah, let's go.
Thanks everybody for joining us today. We're really excited about having you all here today.
AC is going through this side right here and completely around to the DC.
We're going to go through our 5 top recommendations.
When they actually have the power supply up there, and it could be several years, it could also be a few months.
And TRC, we're a specialty partner, right?
Hey, Melissa, before you go, we're claiming to be experts. How do we train and bring people up to that level of expertise?
Okay, that's a great question.
You can see right there the benefit of not having to spec this guy in order to perform the peak function that this smaller product can.
All right, Melissa, thank you so much. You guys ready to kick this off? All right, this is a TRC Power Show Live where we bring to you all things power. We're really excited to have you today. I'll briefly introduce myself and Mike here, and we have a special guest appearance here today. My name is Stephen Lager-Mercino. I'm president here at TRC Electronics. I've been in the electronics industry for 25 years, and all my experience has been with power. Mike, you want to introduce yourself?
Hi, I'm Mike Patania, Vice President of Engineering here at TRC Electronics. I lead an amazing team of engineers here. And most of my career, for the last 25 plus years, I've also been in the power supply industry.
We also have a special guest here today from one of our manufacturer partners, XP Power. How you doing, Ken? If you want to introduce yourself real briefly, so for those of us that don't know, Ken Smith.
Sure. My name's Ken Smith. I'm one of the applications engineers here at XP Power. I've been with XP for, 22 years and change now, doing the applications role. So trying to assist customers with selecting the best power supply for their given application, making recommendations to, bounce off of, because there's always more than one way to do it, and pluses and minuses for each one. So happy to be here, try to answer any questions we can.
Well, we appreciate you taking the time to join us today, and we also appreciate the time all the guests here have taken to join us. So we're going to go through a particular topic today, the AC to DC power supply selection essentials that we find is really valuable. And also, I want you to stay tuned because later in during the show, we're going to have a really amazing offer, exclusive early offer for the guests on this webinar. So stay tuned for that. But let's get into the topic here. And guys, for all the guests, if you have any questions during the course of this show, either raise your virtual hand, type the questions into the chat. We'll make sure that you get all the questions you need answered, and we'll get you all the information that you need. Our goal here is to help you become more successful, especially with AC/DC power supply selection, whether it's an traditional AC/DC power supply or even an LED driver that's converting AC to DC voltage. So let's get started here, guys. I'm really excited about this topic because this is where our expertise lies, and we add a lot of value to clients in the electronic manufacturing industry with selecting the right power supply. And there's 7 essential components here of selecting a power supply to make sure that you get it right the first time. And what we find here at TRC Electronics, engineers like to do a lot of power supply selection on their own, especially now that websites are so evolved and there's so much information there on the web. And when engineers come to us with a power supply that they've selected themselves, we find that 50% of those engineers have not been selected the best product that's available on the marketplace, and there's all these different considerations. So what we're going to do is we're going to walk you through the essentials that we do here at TRC Electronics so that you're better informed and empowered to select the right products for your applications, which is really going to save you time, money, and also help you become more successful in your profession. So let's get going here, and I'm going to share a little slide here to get it going. Okay, so AC/DC power supply selection essentials. There's 7 elements here in selecting an AC/DC power supply, and that goes with starting with the input voltage, the output specs, looking at operating environment, features and functions, considering your safety and compliance requirements, mechanical characteristics, and finally, which is often overlooked by engineers, your commercial considerations. So Mike, let's start here with the input specs.
All right, so this is when we start the power supply selection, the first thing that we ask is what the input voltage is.
Right.
And the reason for that is really need to know what the system is going to be plugged into. You're designing a machine, you're designing something that is going to be either plugged into the wall outlet or it may be hardwired into the AC system of a building. And it's important to know, is this going to be just a 110 volt for most, North America in some countries? Is it going to be 220? Or is it going to be a dual or three-phase solution? Usually, typically for higher power, we're going to need more AC input power, and therefore three-phase would be used.
So it sounds pretty simple, just input voltage, but there's pitfalls here, right?
That's right. If you don't select the right one up front, what's going to happen later on is you're going to go down this design, and you may realize that now you may have enough space for putting in a three-phase system, especially if that's the case. Or likewise, you may think about three-phase, but you have more opportunities where you need to plug this into installations where you may only have single-phase capabilities.
Right.
So this is something that we ask, and many times what happens is we get into that discussion where the customer actually says, hey, that's a great question, let me find out. And that we've already created value right there.
Right. So you want to talk about some examples possibly, like with some AC input ranges that we have here in our selection?
So one of the things that we also ask is we ask about power factor correction. In some cases, power factor correction is not a requirement, but in all of Europe, power factor correction is a requirement because of the efficiency of the AC grid and the way that we pull power from the AC grid. So that's important. And then finally, we have power supplies now that are capable of providing wide range input. So you can have inputs as low as 85 and outputs as high as 277 and even 305. As a matter of fact, one of the ones that I want to highlight, if we could just pan to this camera here, is the XP Power LCW series. This is a 150 watt power supply. It's an industrial power supply, but it is able to go all the way to 305 volts. Now, 277 and 305 is more of a lighting spec, but one of the things that we find is if you can operate at the 305 level, you also can withstand some higher voltage surges that may be present at that point. And Kent, you're online. If you could share with us some success stories specifically on how that product has been helping your customer base?
Yeah, so that product has been is a great one for what you said. One of the big applications, like you mentioned, is lighting. Can be used a lot of large scale buildings, warehouses, factories and such. They run 480 three-phase into the building and around. And so when you split those phases off single phase, you get the nominal 277. And a lot of I've done some jobs with customers where they're retrofitting an existing building and basically all the lighting is wired at 277, but now they're converting to LED applications. And so you can use a traditional LED driver in some cases, but in a lot of cases, customers would prefer to use a more industrial type of a power supply such as this for those types of situations. We also see it in a lot of box build, large scale power systems where they might have a very large three-phase power supply to give bulk, 48 volts, 60 volts, something along those lines, but they need to run a bunch of relays and EMO switches and things like that off of a dedicated 24 volt. having that wide input range allows them to either run it off of a separate single phase, 220, 240 line, or even again, split the phases off and just use one phase and get a 277. And that gives them just a little bit of 24 volt that they might need, or perhaps a 5 or 12 for, some sort of computer thing that goes in there, without having to try to find a 3-phase, 100-watt power supply, which would be extremely difficult to find. So it gives customers another option in that regard.
Yeah, and that's a great point, Ken. When you have the availability of a power supply that can operate on a 277 line, a customer doesn't have to worry about bringing in another transformer feed and having to reduce that voltage from 277 down to the 220 level. So that's an additional savings on the AC grid system, and it also provides a manufacturer some flexibility of the actual system itself.
Right, and it allows a customer to be able to give one product that could be used in a lot of different installs without having to have a different part number, say, okay, well, this is the one that we're shipping to Europe, this is the one we're shipping to North America, and this is the one that gets used on a 3-phase application. They can have one component system to be able to do that. And a little bit more universal standpoint can be a big benefit as well.
That's awesome. Well, thank you for that input, Kent. And while we're on the topic of AC inputs, one of the we had a webinar last year about the top 5 mistakes, and one of the mistakes that is overlooked sometimes is the derating of the AC input. So most power supplies, they'll operate down to 85 volts, but there is a little bit of a catch. At 85 volts, there's more input current that goes into the power supply, and that could overheat the internal portion of that circuit. So what most manufacturers do is they'll derate that power supply by 10 or 20%, or they'll ask the system designer, make sure that you're not operating at full power when you're in that level.
Right, so all power supplies will have an AC derating curve, and knowing the exact AC voltages that you'll be operating at are critical, because you need to look at that AC derating curve, like below 110 or 100, you could have derating. But even if you have a higher power application and you're using a higher power supply, you could have maximum power at high line, but at low line, you could have tremendous amount of derating. So just being aware and making sure you're going through that can save you a lot of time, because once you go through the selection process, you get your prototypes, and all of a sudden you get into a particular environment you're testing, and bam, you just did overlook something, and now everyone's looking at you, hey, why didn't you think about that?
Yeah, and before we get off the AC input topic, there is some emerging technology that's out there, especially in the battery testing world, where you need to bring in an AC input to test a bunch of batteries. But many battery manufacturers, then once they have to test, they have to discharge those. Once they charge the batteries, they have to discharge those batteries, and that goes into the air in load. So one innovative product that has been launched recently is this BIC 2200, which is a bidirectional power supply and inverter. So what this product does is, this product here is able to take in AC input from the grid and supply a DC output to charge batteries. Now, once those batteries are charged, now you have to discharge the batteries, because you have to cycle them. So what this product is able to do then is take the battery voltage that you just charged and convert it back to AC power, and now you're using the grid as the load to discharge those batteries. So essentially you're recycling that energy. And this product here has actually got some other nice hidden benefits or features that are not well known. We can actually use this product in certain applications. We can use this product to load power supplies, and the power supply loaded can actually be dumped back into the grid as well. So for life testing, for applications where you need to load the power supply for long periods of time, why not just use the load, which is the AC grid, and recycle the power back? So there's some great benefits on that one.
Very good. All right, so let's go to output. So next essential of selecting a power supply correctly is output. It seems pretty clear here, but all right, so what's the specific DC output voltage that we are looking to convert that AC voltage to? how many output voltages do we need in our system, what's that maximum current, and really what's really important is understanding the type of load and the load characteristics. Mike, you could talk a little bit about this.
Yes, and when we're on a power supply selection call, we're going to spend a lot of time here because everyone pretty much knows what the output voltage is going to be, but the question is what else is being loaded in the system that may require other power supply voltages. So we ask that question clearly, and then also what is the maximum current, because that obviously gives us the power that we need. But here's some of the things that we get into, we dive deep, we talk about load characteristics, whether they need a peak current and what the duty cycle of that is. There are some systems out there, especially if you're turning a motor or you're actuating a relay, that there is a peak inrush current that's required that the power supply has to be able to deliver. And if you're not picking the right supply that has that peak capability, you're also now, and if you're aware of it, you're actually sizing the power supply a little higher than what you really need. So that's one aspect. And then coming from some of the top mistakes that engineers make, if they don't ask this question, they don't know up front, what is the load protection of the power supply? Is it a hiccup type load or is it a constant current limiting? Because there's benefits for both. If you're picking a power supply with hiccup load and you need a peak requirement, you might actually put that power supply into perpetual hiccup mode.
This is why you need to be aware of the characteristics of your load with the power supply so that when we're looking at the protection features down the line here, they align with the type of load that you have in your application.
Absolutely. And a hiccup mode could be beneficial if you have, let's say, multiple taps coming off of the same, let's say 24 volt input, right, and one of the taps shorts out, you want to have that hiccup mode protection. So we'll get into a lot of detail here and understanding and visualizing what that load is so we can be on the right path.
Right, and the point is here, you do a little bit of investment on the front end and during your selection process, you're going to save a lot of time during your design cycle when you start implementing this power supply into your product.
And just to turn it over to Kent real quick, Kent, I'm sure you've run into this. Maybe you could share with us some of your experience in this topic.
Yeah, I would say you're exactly right in that this is probably the most important of those different criteria that you have is obviously the output of the power supply. And I always find it good if you can have a good, honest conversation with the customer, because usually you're talking to an engineer and engineers tend to be very conservative. And so they might say, well, they need 500 watts on the output. But then if you can get them talking more about it, it might be they need 500 watts for 100 milliseconds to start up a motor. But the rest of the time it's going to run at 50 watts. And that's, your classic peak load application. And there might be lots of power supplies where the power supply may ride through that. There may be some way you control the power supply. You can do something else so that something like a 100, 200 watt power supply, or maybe even a 50 watt power supply with the right criteria may work just perfectly and be a lot smaller, a lot lower cost, maybe more readily available, more options and styles, etc., that can use for that. In other applications, you really need to have that extra size because it's a constant load depending on how it's being used. So the more information that you can understand about what you need as a requirement and then relay that to the vendor to be able to talk about, the better off you are, because you'll have more options that would actually truly fit your application better.
Yeah.
Great, Ken, thank you. So now we're going to go to the next element here, which is features and functions. I love this part because this is where we get the bells and whistles of the power supply. So power supplies can come with a lot of features and functions. Of course, you want to make sure that you're selecting the power supply that has the right features and functions that you're going to need in your application. But also, you want to avoid a power supply that has all the bells and whistles that you don't need in your application. You may be paying for a power supply that's over-designed for your application. So some of the examples of features and functions that are common here for AC/DC power supplies could be the auxiliary output or the standby output, communications protocols, custom configurable, which are modular type of power supplies where you can custom configure multiple different outputs to your specific application, and we can have a prototype safety certified out the door in 24 hours, DCOK signal, programmability, and the remote functions, as well as redundancy.
Yeah, and so just to highlight some of these features, the 12-volt auxiliary output and the 5-volt standby, these are really nice features because what they do is they're essentially there's a power supply within a power supply. But the difference is that having those features allows you to actually be able to power other components separate of the load in order to use with that power supply. So for example, if you have a microcard, you have a small CPU or Raspberry Pi that you need to operate with the system, that auxiliary solution can really be beneficial there, especially on the 5-volt standby, because these products actually, these power supply outputs do not turn off. And speaking of that, just going back to the remote on-off feature, some remote on-off features, depending on how you need the logic, requires a 5-volt signal. So by using the 5-volt standby, you can actually shut down the power supply main output, but still have the 5 volts to keep everything alive and be able to communicate. So those are some beneficial features. The other one that's emerging, and it's something that's not too popular, it hasn't been too popular, but it's amazing once you start to use it, the PM bus feature. Because with the PM bus feature, you're able to not only communicate with the power supply of what it's doing externally, but some PM bus features allow you to go and monitor what's happening inside the power supply. So by monitoring what's going on inside the power supply, like system temperature or power supply temperature, you are able to now figure out what the life line of that power supply is, and you can also set up some alarms in case those temperatures go higher than what you need to.
And this is where, when we have conversations with design engineers and we learn about their application, there's features and functions they may not even be aware that are there for them. And then we introduce that, and because we can see there's potential value for them using those features and functions such as PM bus, correct?
Yeah, exactly. Because if we bring it, sometimes we'll bring it up in a conversation, like, I don't need that. But when we start getting into why, what's the benefits? Hey, maybe I need to take a look, and it becomes more appealing to them.
Right.
And then, of course, there are DC output signals. So in case the power supply output goes down, you're able to at least have a signal that most likely will be an off signal, so you can verify that. And then one of my favorite is programmability of output voltage and output current. This is very essential for test equipment applications where you need to when you need to bring the power supply voltage almost down to zero. And I'd like to highlight one product here, which is the HDL 3000 series, the XP Power HDL. And this product right here is one of the few supplies that we have that actually can be programmed all the way down to 0 volts. This is very, very good for those types of applications. Kent, can you share with us some of the success stories you've had with this product line?
And can you zoom in on that power supply while Kent's talking about that? Yeah, we go.
Yeah, sure. So this has been a pretty successful power supply for us. It's still, pretty dense for a 3 kilowatt power supply, and has a lot of the features, like you said, the programmability, both for current and voltage, is very big. We've seen lots of applications in various types of test instruments where they want to be able to change either the current limit profile or the voltage setting over different points to test the end system with. We see some customers being able to use it for just various applications. They just program it for what they need at the given time. But we've also started to see, kind of coupled back with that, the PM bus and I2C type of a conversation you were just mentioning there, customers taking some of the application or some of the parts that used to be their system, their requirement to design and build, and just send those signals into the power supply and get the power supply to do what it was that they were trying to do externally later, such as adjust the voltage going to their load in some sort of a ramp up, ramp down type of a situation for whatever it might need to be. One of the biggest applications we've seen for this is, believe it or not, is movie projectors, for cinema types of applications or large venues, where it's actually powering the lights and also the computer system itself that's driving the projectors.
That's awesome. And actually, thank you for sharing that. I wouldn't even have thought about a movie projector, but that's awesome.
All right, so guys, let's move forward here a little bit. You want to move on to the next part? But I think that we have operating environment here now. Okay, so operating environment of the power supply. This is really critical here in understanding this. So what are we talking about when we're thinking about operating environment? We're looking at the operating temperature range. Also, the conditions here, is there moisture? Is it a wet or damp, or is there going to be a dust in this environment? This is very, very important because then we might be considering sealed cases or conformal coating. In addition to that, an environment, what's our cooling strategy going to be? What are our available options in this application? Is a fan an option? Do we need conduction cooling, or do we need the power supply to be convection cooling? And how is the air going to move through the system and ventilation throughout the system?
Yeah, so we'll touch on the operating temperature range, because when we ask this question, it's not about the system environment, but what about the environment that the power supply is in? Now, if it's a fan-cooled solution, it's most likely going to take air from the inside, but from the outside rather, but that may not always be the case. So we're going to ask, where is the power supply situated, and what does the air look like from the inside of the system itself? Because here's where, this is actually another mistake that many system designers overlook, and that is knowing what the correct environment temperature is, and then making sure that we select the power supply that can handle full power up until that range. So many of the supplies we have are capable of operating to full power up to 50 degrees C, and then of course from there it derates, and some power supplies can derate as much as 50% when you get down to 70 C. So that's also an important requirement. The next one is wet and damp applications, because here's, or a dirty location. Here, I could bring up some examples here of what we see when we get a power supply that returns.
Right.
We get a power supply return with a failure, and when we look inside, it's completely corroded.
Right.
And when we ask about the application, well, it was in a hydro environment, let's say a hydropot environment where they're growing plants, or it could have been in an environment where there's actually seawater nearby, and so you're getting that salty air. We've actually had, over the last couple of years in the pandemic, we actually had one incident where the power supply was in a clean room, but there was disinfectant being sprayed, and that disinfectant had some chlorine in it, and that got into the power supply. So over the course of 2-3 months, we actually started to see some residue coming, and actually that shorted the PC board. So that's important.
So when you're looking at the environment, really having a discussion, especially if you're a manufacturer, you're going to be manufacturing thousands of these products, and you're going to market, and brand recognition is really important. Mm-hmm. Having a discussion with a power supply professional about the possibilities of what your environment is, and what your environment at the time you're designing your product could be different. That's like right. In 2-3 years from now, and then all of a sudden you run into an issue, and being able to pivot and redesign your application for that.
Exactly, and that's why we ask those questions, because we're asking questions based on our experience.
Right.
And just to give you an example of an experience we had recently, where we realized that after the fact, we had an application where we needed conformal coating. So what conformal coating does is actually it protects the PC board and components from some of this excessive dust and debris or contaminated environments. But what we didn't realize is that if you don't place the power supply in a specific location to make sure that it's free from water that can accumulate inside, you can run into an issue. And what I'm going to do is just I'm sorry, can you just pan this camera real quick, and I'll just show you an example. So here's a power supply that was in an application. It's conformally coated, but what happened was the inside of the box that it was in developed some condensation. So we expected that to happen, but what we didn't expect was the condensation actually started to rain drip down onto the power supply. And what it did was it dripped down into this area and started to accumulate. And this happens to be the AC input. So as a result of that constant accumulation of water over time, there was just enough water there to actually short circuit the entire AC board, and this is how we...
Right, so that's the danger of dust and moisture, is that it's conductive, and you're going to have, it's going to arc over in the circuits, and that's where you're going to get the failure.
Absolutely, and even if you have conformal coating can help you with some droplets of water.
To some extent.
But it's not going to protect you against, water ingress, which is, in this case,
it doesn't give you an IP rating.
Exactly.
That's where you got to look for IP rating power supplies. Okay, very good, Mike.
Oh, and then, one of the things that we also want to mention here is the cooling strategies. And there's different types of cooling strategies. So when you're in an environment and you don't want to have some of this air blowing around, you can go with a free air convection cooling solution. And we have a product here, open frame product from XP. If we could bring this up real quick. Right, and this is an open frame 450 watt product that's rated for 450 watts within the specific air temperature and no forced air. So in the cases where you don't want any air blowing around, we have many options available for that, including in some of those options can go into no fan and conduction cooling. So here's a product here that's 300 watts and it has a conduction plate on it. And what this product is it is able to provide 300 watts full power as long as you mount it to a base plate. Now that could be a heat sink, but it could also be part of the system chassis. And then you may have enough metal in that system chassis to be able to dissipate the heat from the power supply and give you full power.
Very good. All right. So let's get on here to the next topic here. Next element of power supply selection, mechanical characteristics. All right, so here's where we get to look at, number one, okay, what kind of size constraints do we have in a power supply? Are there any size constraints? And also maybe there's some special shape considerations that we need to take into system. Do we want a power supply that's going to be embedded in the system or external to the system? That will also affect safety agency and possibly make it easier for you for safety certification. And we have all different types of form factors to choose from, to name a few of them: open frame, enclosed, encapsulated, PCB mount.
Okay, yeah, so this is, when we get into these types of discussions here, we really want to focus in on what is available for the power supply, but not just the footprint of the power supply. What about the environment around it? Will the power supply be able to breathe? And in some cases, we have found that there's just enough room to fit the supply, but no available air spaces around it for the power supply to breathe, and we can run into some situations like that. So it's important to really understand what the actual size constraints are up front and be able to at least make sure that we pick the right power supply. So when we talk about special shape considerations, here we're going back to the application. Is the application going to be something where we could use a DIN rail power? So DIN rail power supply here, these power supplies are mountable on a DIN rail, and most of these are going to be available in a system where you have dedicated input-output ports, a dedicated power and communication box for a high impact, industrial machine. So an industrial 3D printer and just about any factory processing equipment is going to have a DIN rail power supply. And the nice thing about this is that you can design this towards the end of your system design, because when you have all the power budget figured out, and this could be included at the very end so that you know exactly what kind of power supply you need. The environment is pretty much going to be controlled. It's going to be in a cabinet with other equipment, and it's also user serviceable. So the technician can get to the input and output very quickly, and it's nicely tucked away in a special environment.
Right.
And then we have board-mounted power. So here's an AC to DC 60 watt board-mounted power where you can actually embed this into the application itself. into the actual circuit. And so what that will do is it'll give you the ability to condense your power in one spot and not have to create another space for a power supply. You could go right onto the board. This is very great, good for portable equipment that's going to be moved around, or equipment that's not so large.
Right. So these form factors really depend about the application, you know, what the type of system that you have, the size restraints that you have. If you're building a system where you want high power density power supply because you need miniaturization, you need everything to be small and compact and sleek. So depending on where you go, there's also, you don't want to pick a really high power density 2x3 300 watt power supply if size is not an issue, because you'll pay a premium for the value of that high power density.
That's right.
But if your application doesn't require that, this is not something you're going to value, and you're going to overprice your product in the marketplace.
Exactly. Yeah. So those are, again, that's when you're getting into high density, that's extremely important, and that also applies to many of the other products we have. For example, if you need a 450 watt power supply, but you have all the space in the world, this may not be the right solution. You may want to go with a chassis solution, something that will give you more space, but also give you more ability to interface with the product.
Right. So that's that 450 watts.
Yep.
And that's 150 watts.
And that's 150 watts.
So you can see the difference in size. You got four, but you're going to pay the premium for that. But if your system requires that, you're going to value that.
Exactly.
Right. Okay, so let's see. Let's get going here, guys. Next topic here, we're going to get into.
Oh, we have a question.
Oh, we have a question. Go for it.
Yeah,
oh, go ahead, Melissa.
Mike and Steven, can you hear me? Yeah, so I received a question here from a client who's working on a redesign, and they want to know what type part of their redesign is physical space, and they need to get 4 output voltages that are on 4 separate AC to DC power supplies into a smaller solution. They're interested in knowing what type of options we have.
That's a great question. So we do run into this, if you recall from the first question we asked, is how many output voltages you have, because that's also going to determine how we're going to steer the conversation in terms of product. So one of the nice features we have here, we have a modular product here, and it has a 4-channel separate outputs with 1 single AC input. And this happens to be an actual conduction cooled power supply with 4 separate isolated outputs. And the benefit of this is that we can now have 4 different power supplies in one box, 1 AC input.
Right.
And there's a series of benefits here. The first is you have 1 AC input, so you have 1 wire coming in. Secondly, you don't have any EMI issues, because if you have 4 wires and 4 products, some of them could even be operating at different frequencies. You could run into an issue there. And then lastly, having the 4 output configurations, you can apply power to where you need it in the system. We've had a tremendous amount of success here with ATM type products, kiosk products, where you have printers, you have coin exchanges, you have bill counters. And of course, you have the CPU amplifier for whatever sound interaction you have, and a keyboard and a display. All of those just in a kiosk. Think about how many different voltages you have that can be actually satisfied with 1 power supply.
Yeah, Melissa, so what I would recommend is connect that person to one of our team members, and we'll walk them through the power supply selection, and we can make that really quick for them. Because look, normally most engineers are going to take 11 hours doing all the research, going through websites, looking at all the products, thousands of models to select from. And in a matter of 5 minutes, all we need to do is have a conversation here where we rapid fire these qualifying questions and make sure we get all the essentials, and we're ready to provide a solution in a matter of minutes, where we send a proposal. Very good.
Excellent. Thanks, guys. We have another question in the chat from Ronald.
Go for it. Let's see here. One is Ronald. Hello, do you have a dual output voltage 5 volt that is isolated from each other? Yes. So go ahead.
Yeah, so this is a great question as well. If you have a dual output 5 volts that are isolated from each other, it could end up being a modular power supply again. Depending on the power.
Hey, Ronald, what's type the power level that you, so that's your output voltage. You know, how much current do you need from each output voltage? What's the max current? We're gonna, you know, we're not gonna get into the weeds here with it too much. If you could type what your power requirement is, that would help.
It's not much. So the 5 volt I'm using for, good morning, by the way. Thank you for the nice presentation. So I'm using the 5 volt to provide 5 volts to a CAN bus. And that needs to be an isolated 5 volt bus. And the 12 volts I'm using to provide power to the rest of the system. And that's going to go through a couple of step down converters, but the 5 volt power supply, that needs to be an isolated bus, both the ground and the 5 volt rail.
All right, so that's a great question. So one of the things that we would get into is the 12 volts. How much power is around 12 volts?
What would you estimate?
12 volts is about 100 watts.
100 watts. And what does a CAN bus need? A few watts?
The CAN, it has a couple of termination resistors. So the total resistance is 60 ohms. So we're looking at 5 volts over 60 ohm for the characteristic impedance of the bus. And beyond that, every other node on the bus is going to have its own isolated 5 volt power supply. So, you know, it's a few milliamps.
All right, so this is a great point. So going back to our features, we would find you a power supply that has enough power to power to 12 volts, and then look into the option of a 5 volt standby.
Yeah, because there's 5 volt standby is usually like a half an amp.
Right, exactly. So
And you don't have to buy it and provided it's isolated, right?
all 5 volt, the output standbys are going to be isolated
Right.
from.
So
from
here's
the
an
actual
example
power.
where instead of going to an overrated dual output power supply, you just need a single output power supply that's 12 volts, 100 watts with a 5 volt standby. And what we do is we can select that for you, Ronald. If you, one of our team members will contact you and we'll give you a couple suggestions.
Okay, great.
Sound good?
Yeah, thank you. Great answer. Thank you.
Does anybody else have if you have an existing project or a new project that you're currently working on and you need to select a new power supply, maybe it's a new project, new design, or maybe it's an existing project or existing design and you're not your specs have changed or you're not satisfied with the power supply that you're using in a system because it wasn't supply chain resilient and you're running into some issues, delivery or quality or service, just type in the chat and, you know, I'm working on one. And then one of our team members will work with you to get you guys something selected really quickly. All right, Melissa, any more questions before we move forward?
No, let's go.
Okay, let's go to safety and compliance, Mike. Oh, I just might have hit that too many times. Safety and compliance here. So we're talking about safety certifications.
Yeah.
Let's go through this.
All right, so when we're asking about the safety certifications, at this point we may already have an idea of the application, but what is the safety certification? So UL 62368-1, this is actually the standard that that supersedes the UL's 6950-1. So most power supply manufacturers have now moved into this standard. Some are still carrying both standards until it's all done, but the 62368-1 is an industrial standard, but it also covers audiovisual applications. So over the many years of progress that we've made with technology, audiovisual, telecom, and industrial equipment actually all became one. And an example would be a telephone is no longer a telephone. It's an IP device. It's a computer that's communicating, but it's no longer communicating on the standard POTS plain old telephone line. So that would be one example. Or machines that are providing a communication input, like just about any type of device that has a communication port, but is also performing an industrial function. So that's what the UL 368-1 has, and most power supplies are for that standard. The UL 508 is a standard that was developed for DIN rail type of applications. So many of the old style DIN rails still carries the UL 508. There is another standard actually for programmable logic controllers, I believe it's the 60-10-10 standard, which
Right.
I think we have it on our sheet here, and we also asked to make sure that we cover that. And then, of course, medical standards are very similar to industrial standards in terms of safety, but they do have some additional protection requirements that are not found on the typical industrial product. For example, the power supply is going to be fused on both the line and the neutral. So if there's any type of disruption in the system where you have a failure, you'll at least know that you can clear either one of the fuses. The other big one with medical is the use of the monitoring of leakage current and touch current. These are two things that are a must when you're patient connected, and to ensure that you have, in a fault condition, should the ground be disconnected, you don't have that current flowing through a connected patient and through ground or through a conductive path to ground. So those are very common. And then the last one that's common for us is the UL 8750. This is a lighting standard that has been now developed over the course of 7 or 8 years. It's an actual, so it's taken some of the UL 6950 standards for power supplies, but in the UL 8750 there are specific requirements for lighting applications. So these have now been introduced into the marketplace. And then the UL 8750, it kind of depends on where you're putting the lighting fixture. We've actually seen areas where if it's an installer doing some type of an installation with tape lights, not so much of a requirement, but if you're in a big building, if you're in a municipal building, if you're in a building that's involving lighting designers and architects, this is going to be a major requirement, and it's going to be something that's on the checklist.
So before we move forward here with the safety and compliance, so what ends up happening with safety and certifications is it sometimes overlooked by engineers that are selecting power supplies, especially if they're in a rush and they're time constraint. And this is one of the mistakes we see made where it's just something that they overlook because they're selecting so fast.
Yeah, and if they overlook it, sometimes it may be caught too late, because what will typically happen is you've gotten your system designed and you've passed all your internal tests, and now you're going out for certification.
And that kind of that would be an example of that would be an engineer having a medical application but selecting an ITE rated certified power supply.
Exactly. That's one of the worst things that can happen,
Right.
because in that case, you're not going to meet the isolation requirements or the leakage current requirements, and that's going to require you to redesign the entire thing. There's also some points where if you're speccing in a medical application, you're trying to get certified for an industrial, it's going to take longer because the power supply hasn't been tested to all the industrial standards. It's been focused on the medical. So what typically will happen is you'll have to get a certificate of a conditions of acceptability certificate from the manufacturer, and then it's going to be a longer process. It may still pass, but it's going to take longer and it's going to require more dollars to get it done. And that's why there's certain manufacturers actually that have the provided dual certified products. So we are certified both on the medical but also on the industrial.
That makes it easy.
Yeah, it makes it much easier. And Kent, XP has most of the products, if not all, but most of them certified to both standards. Can you touch on how that's been a benefit for your customers?
Yeah, no, that's you're exactly right in all that. Most of our product line is either dual certified, or there might be an option code for a medical version, but they cover both an ITE, the 62368. We still have a lot of 60950 approvals, which are still big for China, Korea, etc. But also the medical safety approvals, which the advantage to us as a manufacturer is allows us to build one product that we could sell to pretty much all types of applications, regardless of whether it is a medical project or an industrial or computer or ITE or whatever type of application. But as you were saying, it streamlines the safety approvals for an end customer. in general, you could go with the assumption of, well, if you have medical safeties, you're really safe, you'll pass industrial requirements. But there are special tests that are required for certain things. And if you go to UL and you only have the medical approvals, but you're building an industrial application, they're going to want to run a lot of other tests. They're going to charge you more money for that. It's going to take longer. So if you can go with a power supply that already has the report that says that little black box is safe, here's the report showing all of the tests are completed, move on. That greatly helps them out. And if you help them out, they're going to help you out.
Yeah, exactly. When we have these conversations, we bring these conversations up in every power supply selection discussion that we have. And there is your 11 hours. We say we saved an average of 11 hours. Just think about the amount of time it's going to take if you're in a safety situation and now you can't get the power supply to pass, or you end up with much further tests and money.
So we covered safety certifications, but now there's also compliance standards.
Yeah, and then with the compliance standards, here's some of the common ones that we run into. One of them is ATEX, and what ATEX really means is explosive atmosphere. It's just that they switched it around. So these are environments that are highly sensitive to any sparking or anything that could ignite whatever atmosphere you have in that situation. So petroleum areas where you're processing gas and all the other fuels, that's a common one for that. So you could be in an industrial application with process control and have that condition. So we'll be asking, we have products that are certified for that, and some of them are special products. They actually will have an EX at the end, right, and there's special models for that.
Optional models.
Yeah. And then we have Class 1 Div 2. That's another requirement. It's more common in hazardous locations for lighting. Many of our LED drivers have this application. And this is for, again, areas where you have vapors that could ignite. And so the power supply has to be designed in such a way that if there is an internal fault, there's no spark that could ignite the atmosphere, the environment around there. The next one is Class 2. So
but you don't put Class 2, right? Class number 2.
Class number 2.
Which is different than Class Roman numeral 2, which is mixed up sometimes.
Yeah, so let's touch upon that. So the Class Roman numeral 2 is a standard, is a spec for making sure that the power supply has some type of insulation to protect it without the use of a ground.
Right, so that's like a Class Roman numeral 2 power supply is going to have a line and neutral connection. It's going to be two.
Right, just a two-prong plug. There's no third
or
plug.
Two terminals on the power supply.
Exactly.
Right.
So these are typical in, these can be actually available in an open frame, where the open frame will have a specific area where you can either ground or not ground. And so that's something that we look into. And of course the adapters, in this case, this adapter here is a higher power adapter. And you'll notice that there is if you could just pan on the camera real quick, this is a three-prong, so this would not be a Class Roman numeral 2. This would be a Class 1 product that requires a ground. So there's some applications where we just don't have that ground available, and we need to protect the end user from any type of shock. So power supplies that are designed with Class Roman numeral 2 have that additional reinforced, either reinforced or double insulation, depending on the class, the design, to ensure that. And then we have Class number 2. So Class number 2 is really a spec that comes off of UL 1310. And UL 1310 is commonly used in the lighting market where you want to protect the end user for any type of injury. So what the Class number 2 does is it protects you from a voltage, from a current, and from overall power. Now, typically, the way just speaking off the top of our heads, we remember that it's 5 amps maximum, or 100 watts maximum, or 60 volts. These are the three parameters to meet a Class number 2. And But there's also another spec that is very similar to class number 2. It's not explained very well, and it's the LPS, the limited power source. Now the difference with that is that the limited power source is very similar, but not exactly the same. The curves are a little bit different, but it's also referencing UL 62368-1 or the old UL 6950. So the limited power source is very similar, where it says, okay, I'm going to make sure that my power source is not going to create an injury or a death situation for an end user in the case of a fault condition.
Right. So we have past mill standards, semi F47, but because we want to make sure we have enough time here, EMI performance. Let's just browse. Let's just touch on that real quick.
Yeah, this is a very common thing. We will get 1 to 2 questions a week on EMI performance, and so many times customer assumes, well, if I have a class B compliant power supply, which is a 55022 class B, that if I put that in my system, I should be good to go. But what typically happens here is the common problems we get is wire dressing. How are you wiring the power supply to make sure that the input and the outputs are completely separated? That's the most common issue. And then, of course, what is the power supply load? Is there a CPU that has a clock frequency of 2 gigahertz that's creating harmonics, or is there any other type of load that's now injecting that frequency onto the output of the power supply? And if you don't have the wire dressing correct, you could end up getting that right through the input and having a conducted EMI issue.
Right.
Then the last one is radiated, which is really a component of these frequencies getting radiated out by all these wires if they're not completely dressed properly. And then additionally, you may have to put some additional shielding. This could be a topic all on its own.
That's right. So final aspect here is commercial considerations, and we don't want to overlook the commercial considerations here. And what are we talking about? Well, reliability, warranty on a power supply. What type of reliability do we need? Is my product going to be in the marketplace for 2 years and it's something they throw away, or is this something that I need to have reliable, and that's my product's going to be in the marketplace for 5-10 years, and reliability is really important with my product. Lead time and availability. So this is about your timetable. So you may be able to get a prototype out of stock and shipped to you immediately, but what's your timeline look like for your project? How is it going to develop once it gets out of the development cycle? Are you going to need something that you're going to be able to order quickly and get off the shelf? Or is this something where you have a lot of visibility and you'll be able to order in advance? You want to understand these commercial considerations and have a discussion. And this is something you will not be able to figure out by just browsing on a website. You cannot figure this out. You may be able to get a snapshot of what the present availability is, but you will not be able to understand what it will potentially look like in the future. And having a conversation with someone that's knowledgeable and that can speak to that can save you thousands of dollars in expediting fees and lost business because you picked a power supply that is not only the right power supply, but there's the right power supply can be delivered when you need it. So like I said, also the lifespan of your project versus the power supply, when we talk about reliability, but what if you pick a power supply that's an older design and your project might be, have a lifespan of 10 years and you just designed in a power supply that may end up going end of life in a few years. And the people that are familiar with that generation of that particular power supply can predict, hey, this is more likely not to be available for the lifespan of your project. But we do have a new generation that you may have overlooked. Let us get you onto the new generation because that's going to have a greater lifespan. And finally, supply chain resilience. Make sure that you're selecting a product and that's going to have supply chain resilience, because if you don't pick a product that's got supply chain resilience here moving forward, you could, when this happens again, which you can predict it may happen again, you want to be prepared. All right, so very good here. So this was great, guys. Just want to make sure, Melissa, that there weren't any more questions in the chat here before we go, and I want to make sure we get them answered. I also, if we could just, Ken, you're unmuted. Ken, I want to thank you for joining us and dropping a lot of very valuable knowledge. We really, truly appreciate you, and we appreciate our manufacturing partner, XP Power.
Yeah, thank you very much for inviting us along. This was fun.
Very
Anytime
good.
we can help.
Absolutely. We'll do it again. All right, everybody. Melissa, we're good to go?
Yes, we are. And Stephen, just to top that off, that last component is something often overlooked. And guys, we can solve that challenge by having a conversation with our power supply specialist at TRC. You can reach us at 888-612-9514. We're here to help you. We're going to solve your problems.
All right, very good. Thanks, everybody.